Okay, so let's get started, I would say. So, hello everyone. Thank you for attending this wonderful event. We've prepared quite a while for this one, and I'm very happy that we had so many people joining to actually listen and see what we've done here. So, this is going to be a fairly big product release for us. And let me guide you through this stuff, and let's hope we can build something together on top of what we're going to show you here. So first of all, as you might know, we are a Postgres company which has various offices around the globe. So we have people everywhere, basically the world. Our headquarters are here in Austria, but we also have offices in Estonia, Switzerland, there's Poland, there's Uruguay, South Africa is important. And we also have recently just opened up in India, and there are more locations to come, right? So we've been doing Postgres for 25 years. So that's basically everything I've done my entire life. I think this is my 27th year of Postgres. So it has been quite a while. And I think we're one of the few companies here that are still independent and that are not owned by some whatever investor driving the decisions, right? So I've been doing Postgres consulting all my life. And what this basically means is I've been in the field a lot, right? And I've always been wired in a way that we're trying to solve real world problems, right? So what can we do to make databases faster? What can we do to make it more scalable? What can we do to give a bigger platform, a better platform to everybody? And what can we do basically to make this more useful, right? And what has really, really stunned me when this entire artificial intelligence stuff came up a couple of years ago, that everybody was talking AI, but apart from the big players, nobody had anything to show for, right? So everybody was saying, we do UI, AI, we do whatever, but nobody ever had something to show for, right? So everything is great, everything is super, but what is super? You know, what is it actually you can really do, right? So what I noticed over the past 2 to 3 decades, when it was really traveling the world, or when our consultants were traveling the world, or when our support engineers were listening to people's requests, you know, what everybody likes is things that actually exist, right? Nobody can process data with a PowerPoint. Nobody can process data with an announcement. Nobody can process data with a promise. Nobody can build a solution without real people, or without even building a solution for a problem nobody has thought about, right? So the most important thing is actually to have something that really does exist, right? So everything we focus on for entire career is things that actually exist. So what we're going to show you today is exactly going into this direction, that we want to show you some real use cases, some real solutions, some real examples, and not just one more announcement that is just consisting of some nice whatever, you know, it's going to be great, you know, stuff like that. So what has been driving us for our career, I recently stumbled over a nice quote, actually, when I was waiting on an airplane somewhere. It says, there are only 2 worthwhile speeds: instantaneous and walking, right? So either you walk somewhere, or you just have something that is happening. So by the way, this Mr. Dijkstra was also the guy who was doing this shortest distance calculations. So in case you don't know the guy, okay. So let's keep this in mind, that that's actually what we're aiming for, is to solve a real problem, do it quickly, and do it for real. Okay, this leads me to the announcement we've been working on for quite a while here, which is a lakehouse for our Scalefield product, which is our Postgres automation. And the idea is really give people a real solution to real problems, name the problems, provide a solution, and show existence. That's exactly what we want to do here. Okay. By the way, if there are any questions on the way, feel free to put them in the chat, and I will try to answer them as we go. Okay. So first of all, let's discuss what it really means to do database work. You know, back in the old days, somebody loaded some data, did some group by statement on top of that, and at the end of the day, you had some numbers, right? But the situation has become way more complicated and way more hybrid, right? So first of all, when it's about ingesting the data, there are various data sources where data might come in. You might have data from relational databases, you might have data from web interfaces, you might have data coming from non-relational sources, you might have sensor data, you might videos, documents, whatever. So first of all, the data sources have become more diverse. So obviously we have to handle that. Secondly, the amount of data that has to be processed has changed in a way that in the old days, you know, oh, you have 10 gigabytes of data, a billion rows, wow, that's a lot. This has changed completely, especially when data is machine created, or if it's like a world huge renowned company. And secondly, the analytics side of things is really exploding. So everybody says AI, but what does it really mean? You know, artificial intelligence, first of all, does not replace human intelligence. It's supportive, but if something is stupid, it's still going to be stupid afterwards. And first of all, the reporting side of things has become more complicated. So it's not only about, you know, we have a bit of data, we do a bit of group by, and then we have two numbers. It's become a bit more complicated. So at the core, it's about data, it's about Postgres, it's about integration and having these things done together. But on top of that, more analytics and what has become even more important over the years is data governance and compliance, right? So if you're working in banking, it's compliance and process. If you're working with, let's say, medical data, it's compliance and process. You know, that's what it is. So we have to basically, by listening to what people need, you will digest it into various topics. That is, consolidate the data into something, scale it at store, analyze it, and do reporting on that. So that's the high level view of what data lake means, which is really, lakehouse really means a combination of data lake and data warehouse, you know. So welcome to what we have to show you here. So first of all, how do you structure such a thing, right? First of all, obviously, as I've mentioned already, you have different data sources, databases, documents, etc. And the next layer is usually really scalable storage and automation, right? So it's about automation, it's about reporting, it's about scheduling, it's about integration, which really means APIs, different data formats, etc. At the end of the day, you want to visualize something, right? And this is important because you can create all the data in the world. If you can't give it to somebody in a usable way, it's pointless, right? You might have the best data in the world, but if it's not accessible, it's pointless. So we as Postgres people who are really good with data, you know, ingesting billions of rows, doing wonderful analytics, we still have to keep in mind that eventually data has to be consumed by somebody. It has to be seen, right? So, and that's the purpose of everything I'm going to show you today is have the data, decide on how you process it, make it accessible, and make it in a way that this is really useful to somebody, and then use all the modern technologies to actually do the processing and the handling of those things. Okay, so putting everything together. So what does this mean? If we break this down to more examples, it means importing files, importing relational data, importing multimedia data, make use of language models. I will show you how to do that. Be scalable so that the amount of data does not dictate essentially what you can do. This might be time series data. This has to be integrated with different sources to make it fit together. And finally, storage is cheap, but it's not infinitely cheap. So we also have to see that we can make sure that we can archive data properly, store it more efficiently, and to be aware of the fact that nothing fits all. There's a reason why there is hundreds of technologies out there, and the reason is nothing fits all. And what we did is we integrated a couple of technologies to make sure that we can get as close to global usefulness as we possibly can, because we have Postgres at its core, which is super reliable database with all the infrastructure around it to make it one comprehensive solution. And that's what we're talking about today. So first of all, storage. Eventually, you have to put data into Postgres, and this is usually coming from different sources, right? There are technologies out there, S3 buckets, whatever, SF storage, whatever there is. So we try to build everything in a way that it's super scalable and that it stays affordable. You cannot put everything on super expensive, distributed, high-cost SAN storage. Sometimes you have to compromise and decide on what you put where and how you do this. And what has proven to be super useful is to bring the analytics to the data and make sure that the calculations happen where the data is. That's important for efficiency also. So everybody is talking scale, but what do we actually mean by that? You know, can you scale? Can you scale? But what is it? What does scale usually means? You know, I did a prototype the other day, and this is actually a screenshot from our blog post here that says select count star from data, and this is Postgres, and this is actually my desktop PC, and it says 1 trillion rows. So if somebody says, can you store a lot of data in Postgres? The argument is, look, this is my desktop computer, and we put 1 billion rows on that. Imagine what you can do with an array of systems. Imagine what you can do if you have access to data center, if you have access to enterprise hardware, if you have access to, you know, distributed computing, right? So to answer the question, Postgres at scale, can it scale? This is 1 trillion rows on my local computer. I mean, obviously it's 3 columns or something, but still, you know, it's something that is achievable. So if you have 1 billion rows, I mean, it's 1 billion rows, right? But you have to think beyond that, because if you have 1 billion people and everybody starts to produce data, you easily end up with this amount of data. This can happen. We've seen that, and we have to reflect that in your thinking, that this is something that is doable with Postgres. So which obviously needs storage formats, obviously needs parallel processing, obviously needs various techniques that are relevant. So given the solution we're going to present today, this is heavily built on parallel processing. That means parallel loading, parallel execution, because traditionally you can easily put more CPUs, right? But how do you read 100 gigabytes per second? You know, obviously it's hard on a single disk. We will get there, a couple of years. But eventually, if you really want to read, let's say, hundreds of gigabytes a second, you obviously have to do this in a distributed way, you know? And it's not only about reading, you have to ingest it. You have to make sure that you stay highly available. You have to make sure that somehow there's safety in the system. And obviously, you want to monitor such a big system in a way. So obviously, we have to do sharding, have the ability to do this in parallel. Often, this is not needed. If you only have, let's say, 1 billion rows here and there, you don't need this type of stuff, like multiple servers. There's a lot of things that can be done on a single machine these days, but you need the option to do this on 60 machines or whatever, in case it's necessary, or maybe just have different types of workload depending, or different type of distribution depending on what workload you have. And especially if you're going into the realm of machine learning, obviously you need to have access to powerful vector processing, like GPU stuff, etc. So it's not only about database scalability. If you go into the AI stuff, it's also about scaling the compute for the models, right? Okay, so let's see. Depending on what you do, you need different types of storage, right? So traditionally, Postgres was based on row storage. This is perfect for many applications. It's not so perfect for archiving time series, etc. So just to show you what column store means, again, it's not something for bookkeeping. It's not something for real-time address database or something. This is really analytics. We're talking about analytics on historic data. So I'll show you some example of what we have here. So I was using 150 million rows of Oracle compliance data, audit logs, right? So this is 120 columns or 110, I think. And if you do this row store and you want to archive that, that translates to 115 gigabytes or more, right? But if you store this in column store, right, you can get this down to 37 times smaller, which is 2.4 gigabytes, right? We also did some experiments with how would you compress taxi ride. There is this taxi data set Uber has put out the other day. So we imported that, 7 gigabytes in row store. But if you go to column store, this is really 6:1. So it's only 1.1. So if you go long-term archiving, if you ingest time series, etc., there is the option to choose between different types of storage depending on your needs. Okay, so this is also important when we're talking about efficiency. So 115 million rows, 110 columns or so can be 130 gigs, but it can also be 2.5 gigabytes, depending on what you want to do with it. For analytics, the second option through Parquet or column store inside Postgres is the better one. If you really want to do line by line, single line operations, it's certainly better to go for a row store and use more storage, but be able to pinpoint rows and things like that. So obviously, it depends on your workload, but you have to see this, that we have options to do that. And that's what we put into all the Lakehouse infrastructure so that you have the choice on the Postgres side and also on the ingestion side, depending on what you need. Obviously, also on the exports. So everybody who is high-tech for all his life is used to command line, but we've reached a point where we have to make the technology more accessible. We can't expect that everybody out there in the world has 50 years of Postgres experience. So obviously we have to bring the technology closer to business use cases. We have to bring it closer to people to make it more accessible, right? So what we did is we made a nice comprehensive user interface for the solution that allows you to basically monitor data, control scheduling, see where the data is, obviously inspect the data, have access management to the data, you know, like being able to define a security policy, decide on who is going to read this data, have system monitoring there, have thresholds there, have alerting there. So this is really about making it accessible to many people, because obviously you will always have your rock stars who are going to use some AI models, who will do some, you know, really hardcore stuff. But also you need somebody in a bigger organization who's going to say, hey, this guy is going to see this data. Hey, this much storage is needed here. Hey, this is the job that has to run every day. You will have data scientists who might not be the hardcore guys on database, but we need a solution that everybody can come together and create something useful. And the only way to do that, obviously, is to have a user interface for somebody. That's exactly what this Lakehouse stuff is about. Take technologies, put this into a central product to make it accessible for hardcore database guys, data scientists, business people, and have the integration to make this central infrastructure to turn data into information, right? Data is pointless unless you draw conclusions out of it, right? You might have a billion rows and they are pointless, you know? But if you turn this data you have and figure out what to do with that, That's exactly what we're aiming for, and this is why I put so much effort into this to basically make this happen. Right? Here's an example, like add a bucket here, and here that's in a free bucket that stores Oracle log, for example, audits. Uh, have the buckets, edit them, have scheduling, load them, see what goes wrong, send alerts, stuff like that, and integrate this into something useful. Okay? So, but the thing is, as I mentioned when I got started, we do AI, and it's going to be cool. Trust us, we have a PowerPoint. This is we have a PowerPoint for 5 years, and trust us, this is perfect. But what? Tell me what, my friend. Tell me what. Show me a screenshot. Show me for real. Give an example. What's the value of this? It's not like you can have a pile of bricks, and believe me, it's going to be great. But you want a wall, you want a house, and eventually, the value of a house is that you can live there. That's the only point of it. So let's make the house and not make the announcements of wonderful bricks and work on the assumption that everything will be great. Let's make it real. So the first thing I made here is based on the central cockpit that is orchestrating everything. I made a simple application with my own tool and showed you. I'm going to show you some things that you can simply do. Right. So, example here, simple use case. Give me a table and ask the thing, what can I actually do with my data? So I put my 130 gigabytes, I believe, of Oracle audit log into a nicely sharded table, and then I ask the system, ask the AI, what can I do with my data? Look, here's a lot of data, 50 tables. I have no clue what to do with that. So tell me, my friend, what can I do with this data? So, and what the model says here, it says, interesting, based on this table, I have 5 useful questions you could ask. So I asked the model, hey, give me 5 use cases for this data, right? So I decided that I want 5 use cases. What users have made most changes in the system? So it says, select user, account star, blah, 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 whatever, right? Or it says, which actions have been taken on the database for each IP address, right? Or it says, what time of the day does most of the audit log actually occur, right? So we start with having data, put it into the system, and then either we already know what we can do with it, or second option is, hey, let's have a system that actually makes suggestions on what you might want to have here. And this can be expanded quite nicely on bigger models, on simple models, whatever. I just showed you a simple use case to visualize what this really means. By the way, in case you're asking, this is a local llama model that produces this output. And this is scheduled because it takes a couple of seconds. So when you create the data inside the lakehouse, what happens is there's a job that checks what you have in the database, and it's going to pre-aggregate those answers for you, so you don't have to wait on this all the time. Okay, so actually find out, what can I do with my data? That's the first thing we want to answer. What can we do with it? How can we create value for that, right? The second thing we have here is, okay, imagine we import some data, let's say customer feedback. You have hotels, you have products, you have anything, really anything. And you have this feedback in writing. Why does it matter? Why do you care? Deeper insights, what does this mean? Deeper insights is marketing stuff, right? What do I mean by that? Imagine you come home to your wife. Your wife makes you a nice dish, and she's going to ask you, did you like it? And you say 3 out of 7 or 3 out of 10. If you tell your wife the soup was 3 out of 10, what do you do with this information? Obviously, you were unhappy or whatever, but how do you fix it? Nothing. 3 out of 10 means nothing. It just means inconvenience, but it doesn't give you a chance to fix anything. So The real information, when you talk to your wife when she's making a dish, you go home and say, hey, wifey, thank you, wonderful, this is cool, but maybe a bit too much salt and it was so spicy, you know, whatever, and please, no cucumber. I don't like cucumber, but more meat or whatever, right? So you give human feedback. You don't go to your wife and say 3 out of 10 for your soup. It's pointless information. So obviously what you want is you give written feedback. The question is, you have to process that, right? And written feedback might be call the hotel prior arrival to get more info, but each time I get blah, 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 whatever, everybody is rude on the phone, right? Horrible service, whatever. That's what you want to know, right? You want to know, hey, nobody was picking up the phone. Everybody was shouting at me. The pool was nice, but the elevator was broken, you know? This is 4 out of 10, but fix the elevator. That's what you want to know, you know? The information you want to know is fix the elevator. They don't tell you in 3 out of 10 that you should fix the elevator. So there's this thing called sentiment analysis, and there are models out there which you can use. And what you can do is basically you can take this information, run it through a model, which is a containerized Python extension in this case, and it gives you a number. Okay, minus 996 might be really bad if you have minus 1 to 10, right? And then you can say, okay, who is the most happy guy? Who's the most unhappy guy? Whatever. So here, obviously in California, we got most postings from this data set, which I pulled from Kaggle. Average sentiment is positive. But what we see in California, there's also a lot of variation in the sentiment, right? If you look at Texas, you know, different story, right? They can obviously see what's going on. You can do this live, you know? So you take the data model, you integrate with Postgres, the Lakehouse will orchestrate the pre-calculations, etc. By the way, this is a real screenshot here, which I'll show you a bit later. And eventually, it's nice to calculate the sentiment for 1 million entries, you know, so now you got 1 million sentiments, but what you really want to know is, hey guys, what's going on with my product? How do people feel about this? What do they care about? What are the key issues we have to focus on? What is it, right? So basically, we took the sentiments and we feed it back into models of our choice. So DeepSeek, which is not so good for this one, but Llama was better. And then you see, okay, friendly and helpful stuff. Okay, that's what people care about. Stuff is important. Clean and comfortable facilities. Okay, that's what people care about. Convenient locations. Okay, variety, less for money. Okay, that's good. But there are also some specific observations that something happens to be with Marriott Courtyard in Birmingham, and etc. And we'll also elaborate more on what you can improve, right? So that's an actual use case. You take data, you analyze it in Postgres with sentiment modules, right, which are readily available. You integrate that, and then you visualize that, right? And now you know, fix the elevator, clean your room, not so much salt. All of a sudden, it becomes reality. And that's way more powerful than the PowerPoint, you know? At the end of the day, the PowerPoint does nothing. That's the problem. Eventually, everybody will call you bluff, so do something real. And that's exactly what we're doing here. The next thing is, I grew up at a time where search was limited to equals, where product ID equals 10, you know? That was search 30 years ago. But times have changed. If I ask my mom, who is 80 years old, to basically search for something, they don't search the way we would. You know, I asked somebody some time ago when we wrote a specification for a project, I asked them, what's a customer? And they gave me a name. But what I wanted to know is what's the structure of a customer? You know, it's addresses and people and whatever. But he just gave me a name. You know, so obviously in his head, a customer is a person. In my head, a customer is a set of tables. So we have to bridge that, right? So obviously what Postgres can do here is with a couple of extensions, namely pgvector, vector embedding. I'll show in a moment how this works. We can make search more intelligent, like semantic results. So I was looking here, the search I put in here was air travel literature. And what I got is well worth finding and reading. Okay, that's the title. I read this book years ago on the recommendation of an airline pilot. Okay, air travel, pilot, makes sense. Air traffic, okay, makes sense. Air travel, terms, loopholes, pitfalls, whatever. So obviously, the word literature, at least I can see that, but it's about author and reading and book, etc. But the word air travel literature, if we had looked this up, only this stuff with full text search, we would have found nothing, right? People are used to finding something. Google has trained them, put something into this thing here, and you always get an answer. No matter what you put there, you get an answer, okay? And this is the kind of user experience people got used to with Postgres also, that you want to show an answer. So if there's a typo, if there is anything really, give them either an exact match or give them something that is close. Recently, I've seen typos, you know, especially names or addresses or product descriptions, right? That's just fact. Let's live with that, and let's make sure that that we can actually live with that. So standard search, fuzzy search, AI-based search, and that's a real use case of artificial intelligence, is to use existing models and do similarity searches in hyperspace. So what do I mean by that? What is semantic search? Obviously, apple and banana, if you look at the right side of the screen, are closer than dog and cat on the left side, right? Chicken and wolf and dog and cat, obviously there is a semantic similarity, but also Apple, Google, and iPhone are closer to each other than banana and apple, because they're, you know, apple and apple is not the same thing. Could be a physical apple which you can eat, or it could be a company. So we're talking different things. It's called disambiguization, if I have the English word correct, but basically have the same word, different meaning depending of context. And that's what you can do with a thing called large language model embeddings, LLM-based embeddings, where you take the input, transform it into a vector, and then you do similarity search on those vectors to give you this semantic answer based on a human input, based on human input. Okay, so that's how it works. And this is a multi-layer graph infrastructure and stuff like that for this type of thing. It's a bit more complicated, but you can, if you want to know how this works, you can look it up on our blogs and see for real how you would handle this. Okay, so most of the examples I'm showing here, you can also see how this works in the background for real, right? Time series data. We have time series, we want to do cool stuff. Okay, my friend, what's the cool stuff? Okay, show me the cool stuff. Here it is. In the Stone Age, by the way, the pictures on the left are all Gen AI, so they were not drawing by hand. So this is also a real world application of AI, picture generation. I like the Stone Age computer on the left, actually. In the past, time series meant if storage goes beyond 80%, send an alert. That's the Stone Age way of doing things. And this also happened often with non-monitoring related data. So simple thresholds. If more than 4% of payments are wrong, then do something. That's the Stone Age part. But how do you know what an anomaly is? You got any types of data, and what's an anomaly? For example, if I tell you 10% unemployed, in Switzerland, that's a national catastrophe. In many parts of the world, that's a reduction by 75%. You know, so what is normal? Something simple. What is high unemployment? Different thing in Argentina, different thing in South Africa, different thing in China, different thing in Switzerland or in Europe, right? So what's an anomaly? What is normal? We don't know. And the threshold is by far not good enough to do that. So the question is, what's hidden pattern. And also, if you just look at forecasts, if you look at this time series, this is about air travel. On the left, this is about it's a simple example for air travel. You can find it on the blog also. If you want to predict this time series, obviously seasons make a difference, right? So you cannot just have a standard Stone Age algorithm that just says linear regression. You will never get this orange prediction with Stone Age. You need something more fancy. I think in this case, it's a support vector machine, I believe, something like that. But you see the point, right? Anomaly detection. So what I did was I imported some data for German stock market. Simple, you can find it on Yahoo Finance, simple time series, you take it there and you apply some mechanism to see what's wrong, right? And let's see where in this time series, that is really just very small one, but just for the sake of example, I think it's 30 years worth of data or something like that. Where are the anomalies? Let's find anomalies in a time series people might be reasonably familiar with. I've just taken this example because what I'm going to see is obvious. So let's look for anomalies. So the dark blue thing is changes per day. So obviously, if it goes down, we got minus 10%. If it goes up, it's positive. So it's changes on stock market performance day by day. And the blue thing, the light blue thing, the score, is the anomaly score. So how normal is this behavior? So if you look on the left, you do see changes, right? There are drops, 3%, 2%, whatever, but the anomaly score is low. But if you go further into the middle, you will see that the anomaly score goes up, even if the pattern, doesn't show bigger thresholds. The thresholds stay pretty much the same until September, right? But all of a sudden you see that we found an anomaly. And guess what happened in October 2008? Well, in case you don't know, let's ask the AI. So what this does is, first we import the data, CSV file in this case, through API call, Yahoo Finance. We put it into Postgres. We apply the code that finds the anomalies, right? And then we take the outcome and feed it back to the AI model to tell us, hey, my friend, what happened during those anomalies? So this is automated, so we take the top 50 entries, feed it back to the model, and the model says, the list appears to be an historical stock price chart of German Stock Exchange. Actually, we told the model that that's the case. Ranges from blah, 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 whatever. October 2008 was the tumultuous month of global financial crisis. So I would consider the global financial crisis in 2008 to be an anomaly. So this is a real world example. Take a time series, describe what it is, find anomalies, do some statistics on that, feed it back to the model and get an explanation what's going on here. So this is not only possible for stock data, you would use it for time series. We recently had an example where somebody was using sound data to find turbines that are gonna break, or chicken legs and whatever. Many use cases for that. They just try to show you something that you might know, okay, there was something going on the market in 2008, okay? So that's a full pipeline, obviously with a tiny data set here, but you can do this at scale, obviously. Right? As I mentioned before, you can have data, and some people like black white screens, hardcore guys, but let's make it accessible. So what the Lakehouse really does here is we can visualize the stuff. So obviously this is based on our CYBERTEC low-code platform, which we have been using extensively recently for various projects. So there is the Lakehouse cockpit, right? That allows you to monitor the processes, see which data is injected, see how much there is in column store, see how much there is in row store, see what's going on in scheduling, configure buckets, stuff, administration. And then We have the CYBERTEC side of things where you can say, hey, data scientist, according to compliance and row level security and permissions and group, here is your data. We deployed you the database already in Scalefield, which is our Kubernetes automation. And here is your data, my friend. Here is your AI toolbox. And this is your VCVig editor so that you can visualize data, you can extract data, you can work with it inside the system, outside the system, whatever you prefer, right? And you can use everything there is in the book in terms of models and things you might need. It's extensible. So obviously, when we're talking about visualization, we're also talking about maps and stuff like that. This is, again, the Uber data set that was released to the public. What we did was we did some density and put this on maps. If you click on this needle, you will see some data being displayed. You can see, okay, at midnight, many trips. 4 in the morning, a third of that. You know, at 9 o'clock, more, right? By the way, it seems that people tip most at 7 o'clock in the evening and when they come home drunk. So if you want to be tipped, make sure that people are drunk when they go home, obviously. Hell's Kitchen seems to be the area where people tip, right? So obviously, the logic has to be somewhere. So we also have a graphical user interface where we can define functions, queries, expose everything as API, assign permissions, have syntax checking. What you see here is the real Postgres parser and real syntax highlighting. There is bindings for that, so you can do that. So this is obviously available. So import, visualize, have the business logic visualized, have permissions visualized, so you can assign roles, and that's how we do it. To rehearse back on Scalefield, Scalefield for us is a fully Kubernetes-based thing, which allows us to run Postgres, Postgres Enterprise Edition, our migration tool chain, the local platform, and an MS SQL compatible service. And on top of that, this will host, or already does host the Lakehouse product, so that you have everything in one component, which gives you a single compliance report, single infrastructure to basically have more Postgres databases, to access your analytics, to access your Lakehouse infrastructure, have all the compliance stuff in BGE, have an Oracle migration infrastructure from Oracle to Postgres, and build your own applications and APIs so that you can visualize something, that you can have workflows, have forms, have charts, etc. And also, if you're moving from MS SQL to Postgres, there's a thing called Babelfish that makes Postgres expose itself as a TDS compatible service, which means like MS SQL, which allows you to cut costs on the MS SQL side. They can run everything you have here in one platform. Everything you saw here is one Helm chart, right? So you can deploy this on Kubernetes, OpenShift, on a cloud service of your choice, depending on what we need. What we need is basically Kubernetes infrastructure, and that's it. That's what Postgres deployment inside Scalefield looks like. You can create your instances. Everything is high availability by default. You can have multiple nodes, do storage accounting, have direct access to the support help desk, and basically have all the components in place that integrate directly with everything you've seen. So what we tried to do today is to show you that there is a world beyond PowerPoints. There is a world beyond announcements that have been around for years, but nothing happens, you know. If you want to check, did a simple check for me to see if something is real. Go to Google, do image search, and then you know. But as I said, we put everything together here. The website should have been out for an hour now, or half an hour maybe. So if there are any questions, put them into the chat, reach out to us, call us, get in touch. And yeah, obviously you are, we can put things into the chat, right? If you have any questions, anything, just get in touch with us, share the story, right? And tell people that AI is not just a buzzword. If you really do this, you can do this for real. You can really integrate with Postgres, and you can do this for real world examples, for real data, etc. We will show some more things in the days to come, more examples, more use cases, more screenshots, more screencasts, more videos, more real applications. So we put something out. In general, as you might have noticed, we've been doing Postgres for 25 years, right? So we do, everything is obviously covered with 24/7 support and round the clock, follow the sun in multiple languages. We do a lot of open source work. If you check our GitHub, there's a lot of stuff out there. So yeah, any questions? Connie has just posted the link in the chat. So this stuff is going to be expanded. And if you want to know more, just reach out and we schedule a meeting so that you understand which problem are you going to solve, what's the best way to do it, etc. So just reach out. We do one-on-one sessions with you, so that you don't feel like in communist world with everybody in the same group. So we really try to focus on your problems, your scalability issues, and whatever there is. So, any questions, anyone? Feel free to put them in the chat. And it's time for a new picture, I believe. So let's wait for a couple of minutes to see what pops up in the chat. And yeah, thank you everyone for using your Thursday afternoon for this. This is much appreciated.
Thank you, Hans.
Oh, you're most welcome. Hi, Pete. Let's see what we have here. This is my favorite example. We tried this on various data sets, so it's stunning what you can see here. I mean, I've seen cases where somebody was calculating apartment changes out of elevator data. So this is crazy what you can do here. Also semantic stuff, just to go back here. Yeah, we have this architecture guidance for the deployment guidance. Is there something coming for sellers to explain? Yes, there is. If you just reach out to us and we schedule a meeting, we will show you what we have. Obviously, what I did was just a product release here, so we're just trying to show the real stuff, but there's a lot of material around that. There's PDF, there's white paper, there's a lot of stuff. So please get in touch and we do a one-on-one. There's also some enablement sessions and tutorials and things like that. Obviously, we can do that. Yeah, thank you. Yes, in person. That means not just in preparation, but also in person. Do you have any example on how one can analyze Postgres logs and monitoring data to find anomalies? You are actually talking about my pet project I'm working on at the moment. I thought about this for a long time, and there is something going to happen in this area for all the compliance stuff that's going to be released shortly. Something in the making. Something in the making. And yes, one more question I got here was that which Postgres extensions are included in Scalefield? What vector indexes are supported? Basically, all the indexes we have in BG Vector. So there are two types of them, depending on what you want. As far as the extensions are concerned, what we use here is various things. There is a Parquet extension, there are a couple of foreign data wrappers, there is some Rust code that is feeding some data. For the Oracle audit logs, we use a C application that is orchestrating the Oracle audit trail purging. That's the complicated part here is not Postgres. It's about the Oracle interaction, which means bugs in Oracle. So there's a couple of things in there. There's PG timetable, obviously. There are some more analytics extensions like k-means and for clustering, etc. And there is also PG container so that we can run code in a trusted way without compromising security. So there are multiple extensions on that. But the good thing is we control the spillover images for high availability, and we can control what we want to put there. So it's pluggable infrastructure, whatever is needed. A lot of the data you've seen is coming from Kaggle, and the Scalefield also has the ability that if you deploy Postgres instance, there's the notion of a data set where you can actually, when you create the database instances, you can already load data sets you have put into your infrastructure for your data scientists. There are a couple of options here, but I can show you, no problem. Any more questions? Basically, will CYBERTEC LakeHouse be separately licensed or bring it to add PGE? PGE is running a lot of this stuff. Some people prefer to run it with standard Postgres, some prefer to run it with PGE for mostly for the compliance features. So both of this will happen. What will happen in Scalefield? Soon we will release to the public a full compliance integration for Scalefield, for Oracle also, so that you're running Scalefield for Postgres compliance, which we have already, but also for Oracle compliance, so that you have all this stuff in one. And the Lakehouse stuff, for the moment, it's integrated in Scalefield, but for now we have it as a separate thing we ship, so it's not in the standard release we ship to everyone. So this is at the moment for like the extended version of Scalefield, we can say. As for a click, I like the expansion of analytics data AI use case solution. Cover more needs at customers with no vendor lock. Yeah, the important thing is the UI stuff is everything is product, but the underlying technology is open source. You know, so the Postgres operators, the models, the clustering algorithms, whatever. You know, so even if you strip away our product side, you still have a fully functional stuff which we can help you with. It's just less automated, let's say. You know, no visual UI for scheduler, no UI for Parquet. I mean, Llama exists. It has been released. It's there. You know, we just made sure that it's an integrated solution with a graphical user interface. That's the important part, so that it's usable, right? Exactly. It's about the tooling to make it accessible. Because imagine you're sitting in choose a country, right? And you're working with 100 people on the project. Not everybody speaks assembly, you know. Not everybody speaks fluent analytics, right? Not everybody speaks fluent AI. Not everybody speaks whatever. So we need to make it accessible also to fix the HR issues companies have. You know, the technology is there, but you need somebody to do it. And the lower the boundary is, the more people you can bring on the project to actually execute on them, right? Okay, any more questions? Oh, thanks for the positive feedback. That's always much appreciated. So let's feed this into sentiment analysis and see what it says. Obviously, most welcome. Any more questions? I have one. Sure, go ahead. Just post it. So obviously the feedback is quite positive. It says, this is awesome. Thanks, Hans. Feedback is 0.8, which is super positive. So just to show you that it's not just a screenshot, right? To take this further, will we compete with Snowflake, etc.? I think the world is big enough for everybody. The problem with all those cloud-based solutions is if China wins the war, or if America wins the war, or whoever wins the war, you always have the problem that of digital dependency. So the advantage here is we can run everywhere. We can run on-prem, we can run on the local infrastructure, we can run in your cloud, we can run anywhere. So it's not about competing with Snowflake. I mean, they are maybe slightly bigger than we are, you know. The world is big enough for two solutions. Okay. Any more questions, anybody? Feel free to ask anything. So, okay, any more questions, anybody? Otherwise, yeah, just reach out to Jan and or anybody really from our team, or just reach out to me. I would say thank you for your attention. I hope we could shed some light. I hope everybody is happy. We recorded the session, so if you want to see that, we will obviously share that, and we will keep sharing some solutions in the next coming days, so that more practical examples, more screenshots, so that you can see. Also, if somebody has an idea of a useful AI example you want to see, reach out to Connie, to Jan, or to anybody. Send us what you want to see for real, right? So let's not have this as a Hans had a nice idea and everybody has to do that. Send me what you want to like to see in the AI space, and let's make a demo on that. Let's do it for real, you know, challenge accepted. Okay, cool. Thanks, everyone. And yeah, have a nice day.